This is a complete overhaul of a SIHI multi-stage liquid ring vacuum pump. These pumps are the workhorses of industrial vacuum systems, but they rely on extremely tight internal clearances. If the spacing between the impeller and the port plate is off by even a few thousandths of an inch, you lose your vacuum. Today, we're going to show you how to tear it down, prep the components, and perform a precision vertical stack assembly. We start by pulling the coupling hubs off and stripping down the pump to bare castings. In a liquid ring pump, corrosion and scale buildup are the enemy. You can see here we're using a die grinder and wire wheels to remove all the old gasket material and scale from the casing stages. And in order to properly inspect the vanes, we need to sandblast the bronze impellers. What we're looking for is called cavitation pitting, which is small holes caused by imploding bubbles, which basically destroys the pump's efficiency. Inspection is critical. We measure the shaft journals for runout and wear. If the shaft is undersized, the new bearings aren't going to be seated correctly. In this case, we had to machine a new shaft sleeve. You can see us turning the new component on a lathe here. Obviously, we don't just swap the parts out. If a component is obsolete or unavailable, we have to manufacture it in-house to OEM specifications. Now for the assembly. We build these SIHI pumps vertically. This allows gravity to help us keep the stages perfectly concentric. We start by prepping the stage bodies. Notice we're using a liquid anaerobic sealant instead of paper gaskets. This is crucial. Paper gaskets have thickness variations that can throw off rotor positioning. Liquid sealant ensures metal-to-metal contact for a consistent stack height. We slide the first impeller onto the shaft, followed by the stage casing. We are constantly checking that the impeller is centered within the stage. Next, we need to install the mechanical seals. These prevent air from leaking into the pump and breaking the vacuum. We lubricate the shaft and carefully slide the seal cartridge down. You have to be extremely careful here and gentle. The sealing faces are lapped to microscopic levels of flatness. Even the oils from your skin or a small scratch can cause the seal to fail immediately. Once seated, we lock the seal drive collar to the shaft. For the bearings, use an induction heater to expand the inner race for the bearing uniformly. Once it reaches the correct temperature, which is usually around 230 degrees Fahrenheit, it slides right onto the shaft and shrinks tight as it cools. This prevents any damage to the shaft or the bearing race. We follow up with the lock nut and washer to secure it. And this is the most technical part of the build, setting the end travel. Because the impeller spins between two stationary plates with very tight gaps, we have to center the rotor perfectly. We use a fixture to push the shaft all the way down. Measure the gap, pull it all the way up, measure again, and then lock it in exactly in the middle. This allows for thermal expansion when the pump gets hot without the impeller grinding against the casing. And finally, we install the crossover manifolds. These pipes route the air from the discharge of one stage into the suction of the next, stepping up the vacuum level. Next, we torque down the flange bolts, check the shaft rotation one last time to ensure it spins freely, and get it ready for priming and paint. Make it look brand new. And that's the complete rebuild of the SIHI multi-stage vacuum pump. From precision machining new components to setting those critical vertical clearances, attention to detail is what makes rebuilds last. If you want to see this pump tested on our vacuum stand, hit the subscribe button. Thanks for watching, and we'll see you in the next overhaul.